What's poppin', dogs? Mr. Allen here with some writing of quadratic functions that contain certain points. Now, we could give you x-intercepts, a vertex, 3 random points. It all depends on the scenario. So let's start at the top right here. We have a negative 5, 0, a 2, 0, and 4, 6. Well, these two are x-intercepts, aren't they? Because it's comma 0, right? That's sitting on the x-axis. My y value is 0. And then a random point. So the most efficient method to use here, efficient function to use here would be factored form. So I'm going to write that up here real quick. I would have f of x equals a times x minus my root, or whatever you want to call it, r1, and then x minus r2, right? Those would be my x-intercepts, my roots, just my value there, right, that I have. So to do this whole thing, I got to figure out what this a value is, which kind of reminds me of like when you're doing slope-intercept form, you're trying to find your y-intercept, and you plug some numbers in, you solve for b, you put it all into a final answer. That's essentially what we're going to do here, okay? So I'm going to put negative 5 in for my r1, 2 in for my r2, 4 is going to be my x here, and 6 is going to be my y, which is f of x. So let's do that. 6 goes in for my y. A just stays a. I'm solving for that. My x value becomes 4 in that spot, minus negative 5. I'll write it all out. Then I have x is once again 4 minus 2. That's my r2. These two could have been in either spot. I could have 4 minus 2 here, and I could have 4 minus negative 5 here. It does not matter, right? You can't screw that up. Okay, just make sure you have the negative there because it's x minus r. So we'll leave the 6 alone. We've got a. This is 4 times... let's see here, minus negative 5, so plus 5, so it's 9, a niner. And then we have 4 minus 2 is positive 2. So now I have 6 equals 18a. Ooh, sorry. 6 equals 18a. So now I got to solve for a. Last little step here to get a. Divide by 18. I get a equals, ooh, we can simplify that, right? 1/3. That's dope. That's not my final answer here, dogs. You could do all that work and circle that as your final answer, and you will lose some points. We don't want to do that. I don't want to do that. I don't want that to happen to you. I got your back, okay? Our final answer needs to be a function, right? A quadratic function. So f of x or g of x or whatever of x, h of x, right? Q of x, z of x. I don't know if I do that. Anyways, 1/3 is my a value. X minus negative 5, so plus 5, right? X minus negative 5 becomes plus 5. And then x minus the other one, minus 2. So my x's and my y, or my f of x, stay in the equation as our variables. The 1/3 a value comes in, and my 2 roots are in there as well. That's it. All right. So why did I pick factored form again? I was given my 2 x-intercepts. I didn't tell you they were. Some problems might be like x-intercepts at these 2 spots, or zeros that are negative 5 and 2. It might tell you. But at least for us in Honors Algebra 2 land, I'm just going to list 3 points. You got to use your brain ski here and identify that those are x-intercepts. Factored form is ideal for this situation. Okay? Some may lead you on that, though, in like an Algebra 2 regular class. Now in an Honors class, they might give you a few more steps. So if that looks familiar like they tell you, then you should be good. Okay? My class, Algebra 2 Honors, you got to figure that out. All right, enough of that. This one here, vertex at negative 2, 5, and a point of just 3, 1. It contains that point. All right, some of those will say, and containing this point. I just didn't have the room to write it, okay? Well, let's see. I'm given the vertex. It would seem logical to pick vertex form. Yes? Yes? Everybody agree? Jenny, do you agree? Jenny agrees. She's in here. She's just chilling. All right, so I'm going to write that one out. F of x equals a, once again, we're looking for that bad boy, x minus h quantity squared plus k. A lot of people forget the squared there. We're in quadratics, bro. Got to be a squared somewhere. Okay, so let's go through this thing again. Same idea. I'll do it all in the same kind of color scheme. So we have our final answer. Our work will be in pink. The formula is going to be in that neon yellowish color. So here, my vertex, this is my h, that's so tiny, h comma k. This is my x and my y, or f of x, right? So let's fill those all in. 1 goes over here. A is just a. X is 3 minus negative 2 squared plus k. So that helps you to label those things. And you could have done that here too. R1, R2, X, Y. You could do that, you know, keep you a little organized, right? Then we can just plug and chug. All right, so I have 1. A times, let's see, that's 5 squared. Why did I put plus K? That should be a 5 right there, guys. Sorry. And then plus 5. So now we have 5 squared is 25. So, and I'll also subtract this 5. So minus 5. Do a couple steps here, save some room. So that's negative 4 equals 25, we said. A. And now I'll just divide by 25 to get my A value, which is A equals negative 4 over 25. This one does not simplify. Okay. So we have our A value. Are we done? No. Final answer in blue for the win, f of x equals negative 4 over 25 times the quantity. We have x minus negative 2, so plus 2, squared, plus 5. Don't put plus k here. This is plus 5. That right there is my final answer. I didn't even box my final answer up here. That's half the fun, man. All right, there we go. So we have factored form, vertex form. Now we got to do, yes. Jenny even just grumbled there. She's like, just like laid down. She doesn't even want to do this problem. Notice the space that I have. Yes, this one takes a little bit of work here, but I don't have any x-intercepts. Neither of these are stated as being a vertex. They could be, but we do not know. But I have a y-intercept. That's helpful. It will be helpful. But unfortunately here, guys, we have to set up a system of equations, which is a bit rough. Okay, so all of these ordered pairs are x comma y, x comma y, x comma y. Okay? Now my standard form is f of x equals ax squared plus bx plus c. Now for this one, I'm going to have to set up a few different equations with each of these. But I do know that this is my y-intercept, right? 0, 7, which is that guy right there. So my c value I already know is 7, which is going to save me from having to do 3 equations, this monstrous problem, and only having to do 2. But you have to be able to see that in the problem to take advantage of it. Otherwise, you're just going to go through the whole awful process. All right. So I'm going to set up one equation here with this guy. We'll do this one in blue. All right. So I've got my y is 12. So we have 12 equals, we have a times my x is negative 1 squared plus b times my negative 1. And then we have plus 7. Okay. And I'm going to clean this up a little bit. So we have 12 equals just a, right? Negative 1 squared is positive 1 minus b plus 7. I'm going to subtract the 7 over. So we got 5 equals a minus b. All right, I'm going to box that for now because we are going to use it. All right, next one I'm going to do in orange. We're going to get some blue and orange there because the Bears just won. It was ugly. It was a defense special teams win. But hey, 1-0, no less. So this one here, I got my y is going to be 6 equals, and then I have a times 1 squared. Oh, these numbers are kind of nice. Thanks, Mr. Allen, for making this wonderful problem here. Plus 7. Let's clean it up. I can subtract 7, get negative 1. I'm going to save a step right here. A plus B. Ooh. All right. This one actually works out very, very nice. Almost too nice, but it's okay. All right. So I'm going to put these together into a system. I have 5 equals A minus B, and I have negative 1 equals A plus B. This is already set up for elimination, dude. This is awesome. So I can just go ahead and cancel my B's. I'm left with 4 equals 2A. Now, had they not been set up nicely for elimination, I would have to multiply one of these two equations by a number. Like if this was A plus 3B, I would have to multiply this one by 3 to get the B's to cancel, or by a negative 1 to get the A's to cancel. We didn't have to do that here, which is nice. I have another video, I think, where you do have to do that. But anyways, let's continue. Divide by 2, we get A equals 2. Am I done? Not even close. But let's box the 2 because that is important. I like to box a few things along the way with this one, and I'm not leaving myself a whole lot of room to write the final answer. We'll probably put it right here. I'll move. Okay. Now I got to figure out my B, and I already have my C. So I just have to figure out B, right? This is my C value. So how do I get that? Well, how about I just use one of my two equations here? If I want to get my B, I'll use this one here because b is positive. So we'll do that. I'll do it in green. We have -1 equals 2 is going in for a. I'm going to put it in parentheses even though that's not necessary. I just do that when I'm like substituting to show that I substituted something. That way my eye catches that in the work like, oh, I did a substitution. Cool. But they're not necessary, right? This is still the same thing as just this. So I'm going to subtract 2, make it -3 equals b. And now we are ready to write our final function here. I think I have enough room right here. All right, we're going to do it in blue. So I have f of x, or g of x, or h of x, or any, whatever you want. 2 for a, right? I'm putting the a, b, and c in. 2x squared minus 3x plus 7. That right there, folks, is it. That was a lot of math. It was a lot of math there. A lot of dope math is what it was. So there you go, guys. Wonderful, fantastic writing of quadratic functions that contain various points, x-intercepts and a point, vertex and a point, 3 random points, but we did get lucky with the y-intercept there that you see. So be on the lookout for that just in case. But if it's 3 random points, it's a little bit longer process. I think I have a video on that somewhere, but not in this one right now. Otherwise, you guys, thanks for watching. Have a great day. Spread the love. Tell people about it. Say, what's up? Hey, go check out Mr. Allen Math videos. They're pretty dope. Like it, subscribe it, and have a great day.